everyone, today I will be talking about Lab 3 of Physics 2212 dealing with the magnetic field of a bar magnet. The goal of this lab was to measure and observe the magnetic field created by a bar magnet and then to determine the distance dependence. Some fundamental principles that were used were the Biot-Savart law shown to the right of the screen and the known distance dependence of a bar magnet. The final results for Lab 3 were a distance dependence of negative 2.7625 and a magnetic moment of 3.45544 am squared. To obtain these values, I first had to download a magnetometer app onto my smartphone that could detect the net magnetic field and the X, Y, and Z components around the phone. The phone was placed in a location with no magnetic interference. The only magnetic field that was detected was the Earth's magnetic field, and to make sure of this, the net magnetic field had to be 48 microteslas, while the X component was 0. Then the sensor on the phone had to be located. The bar magnet was then oriented like this picture and moved in a vertical motion up and down the side of the phone. The location where the absolute value of the X component was a maximum and the absolute value of the Y component was a minimum meant that the sensor was in the path of the magnet. This process was then repeated where the magnet moved horizontally about the top of the phone, but where the absolute value of the X component was at a minimum and the absolute value of the Y component was at a maximum. The location where these two values met was the sensor location, which in our case was the top left corner of the phone. To obtain data, I recorded average distances that the magnet had to be from the phone to produce an absolute value of the X component of 20, 140, 160, or 260, 380, and 500 micrometers. This resulted in the following graph. This graph was then used to calculate the distance dependence and the magnetic moment. The slope of this graph, which is the ln of the magnetic field in the x direction, equals the ln of k plus n ln of r, is the distance dependence. So in my case, the distance dependence was negative 2.7625. To calculate the magnitude of the magnetic moment, I used the known distance dependence for a bar magnet where the magnitude of the magnetic field is kr to the nth. The magnitude of the magnetic field, I then plugged that in, so you've got kr to the nth equals u naught over 4 pi 2u r cubed. So in my case, I assumed that r was equal to 1, which gave me the next equation, which is k is equal to u naught over 4 pi times 2u. Now, from our graph, we know that the y-intercept is the natural log of k, which means that k is 6.91 times 10 to the negative 7th. Now we have all the information to calculate the magnitude of the magnetic moment, which is 3.455 am squared. This lab was then modeled using GlowScript and resulted in this image here. The blue arrows represent the magnetic field on a perpendicular axis, while the orange arrows represent the magnetic field on a parallel plane. Using the model, the magnetic field was then used to calculate a 45-degree angle from the magnet, which is represented by the green arrow at the top right of the image. The magnetic field of off-axis was also experimentally calculated. The experiment resulted in a magnetic field of negative 1.33 times 10 to the negative 5th, 9.39 times 10 to the negative 5th, and negative 4.42 times 10 to the negative 5th Teslas. The model resulted in 1.288 times 10 to the negative 10 times 10 to the negative 5th, 3.86 times 10 to the negative 5th, and 0 Teslas. These values are different for several reasons. The model is only taking into account the magnetic field of the bar magnet, but the experiment has to also has to take into account interference, like the magnetic field of the Earth. So we know there was some interference because technically the experimental value should have a z component of 0, which it is not in this case. In conclusion, the final results of this lab were that the distance dependence was negative 2.762, which makes sense because the Biot-Savart law has a distance dependence of negative 3, and we know that because r in that equation is raised to the third, and that's all over 1, so that's a negative 3. And in this case, negative 3 is pretty close to negative 2.7. The magnitude of the magnetic moment was 3.455 am squared. So what if I hadn't oriented the experiment to compensate for the magnetic north, and I had just instead laid out the meter stick wherever at whatever angle in respect to the Earth's magnetic field? How would this change my results? Well, all the measurements would be off because I would not be able to determine which portion of that net magnetic field was due to the bar magnet and which was due to the Earth. So what if I were to stick two identical magnets together end to end and run the experiment? How would my measurements differ? Well, in this case, the magnetic field would be a lot stronger, and this would cause those distances that I measured to be smaller. So thank you for listening. This has been Lab 3 of Physics 2212.